So we've been working on complex fractions, and
Okay, imaginary numbers. Is this the first time you've learned imaginary numbers?
we've done imaginary numbers before. I was meaning like polynomials and fractions, and
Oh, rational quotients. Okay,
yeah, rational quotients. Yeah.
all right. So what do you got?
Currently don't have any material for it, but
Hmm.
can look for something real quick.
Yeah, if you could, because that's quite a broad field. And I don't know what they...
Okay, I found the picture. Let me email that to you real quick.
All right. So you're talking about domains and ranges of some of these?
No, just solving if you're multiplying, like, say, like x plus 1 over x squared plus 2x plus 3,
Okay.
and then timesing that by another one type of those.
Okay.
I like to get those pretty good.
Yeah, I need specific problems.
It's like multiple fractions inside of fractions.
Okay. Yeah, the best thing to do is to send me the problems you're covering.
Yeah,
I
yeah. I
can
just sent you that.
book, but they may not be the same degree of difficulty. There could be all kinds of things that I wouldn't be on same page.
Yeah.
Let me know. There it is. Let's see if I can work with this. May need you to do it again. No, I can make it out, I believe. Yeah. You want to start with 26? Or have you done
Yeah.
some of these?
I haven't done any of these yet.
All right. Let me rewrite it just because this kind of came out. What the heck? How'd you get it to come out like this? What'd you do?
It's just my phone. The camera on my phone is not very good.
Oh. All right. So the instructions are to perform the indicated operations and simplify. All right, what do we have to do first for this problem? We're adding two fractions together. Oh, that's what you meant when you said complex fractions. You meant complicated fractions.
Yeah.
All right. So when you add fractions, what's the first thing you do?
First thing is to have a least common denominator.
Okay. In this case, what is that going to be?
4x squared times 5x.
Let's just leave it like that. There's not necessarily any need to multiply it out. And in fact, when we leave it like this, it's better because we can check and see if we make a mistake. What goes there?
30x, because it's 5x times 6.
Right. Well, yeah, in fact, let's even for a moment write it just slightly different. If we write it 6 times 5x, the reason we know that's correct, we don't have to do any math at all to notice that's correct, because those two will cross out and you're left with what you started with. And that's always the goal whenever you're doing this, is to make sure you do not change that fraction. And so by leaving the bottom unmultiplied, it's much easier to figure out whether you've changed that fraction or not. What goes over here?
So you times that by 4x squared, so it would be 8x squared.
All right. So I'm replacing that with 30x, and I'm replacing that with 8x squared. So what's my final answer? Or at least, it's not quite
So
final,
yeah,
but let's
30, yeah,
work through it.
30x plus 8x squared
Yeah,
over
and
4.
let's put it in order. Let's put the leading or the highest degree polynomial first, just as a standard way of writing it. And now we probably need to multiply that. And the reason it's advantageous now is that I can see that there is a factor that we can take out of the top and the bottom, which will simplify this. And I don't know that I could have seen that as well if I didn't multiply all that together.
Mm-hmm.
So what's the greatest common factor for the top and the bottom?
2?
I think so. Let's see what we get if we take a 2 out. If you haven't taken the biggest one out, you can always go back and take another one out.
Yeah.
But so it's easier to just step your way through it. And now, is this simplified? What else can I divide top and bottom by?
Nothing, because...
How about x?
Oh, an x, yeah.
I can take an x out. In other words, I can take out 1x from the top and from the bottom, leaving that. And that's simple.
You have to factor an x out of both terms on the top, though?
I did. In other words,
Oh, okay.
that's what I had on the top. So I took an x out of both terms, and then I took an x away from the bottom.
I just didn't see you take away the x from the 15, so I was just
Yeah. Now,
making sure.
it is worth noting that if I wanted, I could separate that into two fractions, those two fractions. And that actually gives you something fairly different looking. And then I could change that to 3/2 over x squared. So that would be the same as that, but I don't know that that's necessarily simplified. It probably is not. In fact, I suppose your teacher would say the top was more simplified than this.
Yeah.
But it's worth noting that you could do this if there was some benefit to it. And it does it simplifies that part of it a lot. All right, let's go on. Oh, man. Huh. Program works strange sometimes. These are all even numbered, is that correct?
Yeah, I think so.
All right. Well, let me just get this one down where we can both see it. And again, I don't necessarily multiply those two together. I may need to, I may not. It might be more beneficial to leave them factored. Now, when I'm doing least common denominator, I always do it like this.
Mm-hmm.
Because to me, it's the way to minimize mistakes.
Mm-hmm. So the least common denominator would be 6x times x minus 2.
Good. You don't need the other 6 in there. In other words, it's all we need to make sure is that that's divisible by 6 x minus 2, and that's divisible by, or the other way around. Our least common denominator is divisible by that, and it's also divisible by that.
Mm-hmm.
Okay, so what goes in the numerator on the left?
7x.
And on the right?
On the right. So you're multiplying it by x times 2, so it's x plus 3 times x minus 2.
Okay. Notice how easy it is. As opposed to if we actually multiplied that out on the bottom, it wouldn't be so easy to tell that we had the same thing. You see that?
Mm-hmm. Yeah.
And now it's pretty easy from here. Now, on the bottom, do we ever want to leave that unmultiplied? Maybe. No need to do extra work in advance. Who knows what the top would yield? Maybe the top yields x, or maybe the top yields an x minus 2. You know what I'm saying?
Yeah.
Both of those would be more easily handled if we left this unmultiplied. We probably are going to have to multiply this out at some point, but let's not do it yet. What do we got on top?
7x minus x plus 3 times x minus 2.
Okay, now you got to be a little careful here. Give me the complete answer.
7x minus x plus 3 times x minus 2.
Multiply those out. Definitely need to multiply those out at this point. Because you see that we got subtraction going on. So the numerator is not going to be pure multiplication. It's possible that that 7x will disappear and we have the product of stuff and we could cancel.
But can you cancel the x minus 2's?
Not yet. No, because what we have in the top is what you said, and you cannot cancel the x minus 2's because it's not pure multiplication going on in top.
Okay.
It's 7x minus that. So I'd have to be able to divide both terms. But when I say multiply that out, FOIL those two together and give me your answer.
X squared plus x minus 6.
Not correct. In other words, the reason it's not correct, and that's why I wanted you to do it, is that we really need parentheses around that. Correct?
Mm-hmm.
In other words, I'm multiplying the product, and the moment I put parentheses around that, now when I remove them, it changes this term and this term, the signs on them.
Mm-hmm.
In other words, the moment I remove those parentheses, this becomes a minus x and a plus 6. You see why?
Mm-hmm.
All right. So let's do that. I'm going to remove the parentheses and change that sign to a minus and this sign to a plus. Now that's the same thing that we had in the step above. And this is one of the most common mistakes that I see 95% of my students make. And that is that when you add the parentheses, you have to make sure that you're very careful when that whole thing is being subtracted from something else. Because if it's being subtracted, the moment you add the parentheses, you change it. Now, if I simplify the top, I've got what?
So negative x squared plus 6x plus 6.
Yeah, and then now the question is there any way that that top gets you an x minus 2 factor?
No.
Close, but not quite. In other words, no, not really. How about 6 and 1? Now that would give you 5. So I believe this is a final and acceptable answer. It doesn't make any need to multiply the bottom because I don't see any. I'll just end up with a quadratic over a quadratic.
Mm-hmm.
So I'd rather leave the bottom factored because it's possible that this could have produced an x minus 2 factor. And then I could have really simplified it. And it was close. In other words, by the time I factor out a minus 1 here, I'm going to have x squared minus 6x minus 6. And that's close. If that would have been a 5x, then I could have factored an x minus 2 out of that. I'm not sure a half an hour is enough to cover all these problems. We better do 30 because it's a little different. But I also see some that could use our attention also. What's the least common denominator here?
So factor out the left's denominator to x plus 7, or x minus 7x plus 2.
Now what's the least common denominator?
X minus 7x plus 2.
Okay, so I think you know how to do that one. Let's go on. In other words, that's the key step is what you did already. Let's see, 32, what's the least common denominator?
Um, 3x plus 5 times x plus 8.
Okay, notice you're going to have the same problem here. There's a negative sign there.
Yeah.
So by the time you finish putting the new numerator on it and put parentheses around it, make sure that you don't get your signs wrong on the next two terms. And it's a really easy mistake to make. So, number 36, what's the least common denominator?
X plus 1 times 2x minus 3 times x.
Okay. Let's do one of these at least. In fact, well, these all look tough when you first look at them, but what they are is just a lot of steps.
Yeah.
Okay, I mean, they're either 4 steps or 12 steps. 46 might be 12 steps. But basically, they're all the same in terms of the process you use. What am I going to do first?
Find least common denominator between the two subfractions.
Okay, so tell me what that's equal to. How am I going to write the top? There's the main fraction bar. What goes on top? In other words, what are the two?
2x. So it's going to be 2x squared over 4x times
Hold on.
minus 5 over 1.
Whoa, let's take one step at a time. What does this fraction become when I use a least common denominator? In other words, I've got to find the least common denominator of the numerator, and then I got to find the least common denominator of the denominator. Then I got to flip and multiply. That's going to be my strategy.
Okay. When my teacher was telling me today, he said you need to find the least common denominator of both of the all the subfractions.
Oh. Okay, I've never done it that way. And that is what? 2x?
Yeah, 2x.
Okay, yeah, I see the advantage of that.
2x squared over 4x. Oh, no, yeah, no, there we go. Oh, it would just be x squared over.
Correct, there you go. I got an extra, whoa,
But wouldn't you only multiply the...
yeah. It would be 5x squared.
No, what I'm saying is wouldn't you only multiply the x over 2 in the
No,
LCD?
no, here's actually what I meant to write. In other words, this is what I should have done. I put a 2x there first. That's my least common denominator of all the subfractions, is 2x, okay? So what does this have to be? 10x. In other words, this whole thing has to be 5,
Mm-hmm. Okay.
right? Okay, now we go down to the bottom. We'll put it 2x there. This isn't actually the typical way I do it, but I can certainly see the advantages of it. This has to be 12x, correct? Fill in this.
Yep.
What's this got to be?
6x.
No. Make sure that when you're done, that is the same as that. Got to be just 6. Right? Now it's the same. Am I making a mistake, or I'm noticing a hesitancy?
This is just very different from at least what we were doing in class today.
You're kidding, because I'm doing it the way you suggested, which is...
I know it's still different though. I don't know.
Okay. All right. Well,
I'm doing it right, and I think I'm more used to there not being whole numbers instead of...
okay. Well, I like this method, but, okay, and I've made a mistake here. There's no 2 right here. That's not helping your confusion level there. Okay. Now,
I'm good.
the key is that this has to be equal to that. This has to be equal to that, so forth and so on.
Mm-hmm.
And then you know you've done it right. And I think that's 5, that's 6, and that's 3 over x. So I think I did it right this time.
Yeah.
I made a mistake the first time. That's probably where your hesitation was coming from. All right. So now I can flip and multiply, right?
Mm-hmm.
And the bottom is really 12x plus 6 over 2x. So if I flip and multiply, I know all of those are going away. And what am I left with? 12
X plus x.
Yeah, x squared minus 10x is the numerator.
Yeah.
And the denominator is 12x plus 6. And can I do anything with that?
Mm-mm.
No, not really. I could factor a 2 out from the bottom, but it doesn't accomplish anything, so I won't. And that should be your final answer. All right, let's see if there's any ridiculously hard ones here. What was that one we just did? That was...
I think 38.
It was 38, yeah. And notice that these don't significantly, they're not any different. In other words, we already have a single fraction in the numerator, so this actually should be easier.
Mm-hmm.
And I have no problem at all with doing it the way you suggested, finding a least common denominator for all of the subfractions. So on 39, what is that?
4 times x minus 1. X plus 1, sorry. Just looked different.
Yeah, actually when I looked at it, I thought one of them was a minus and the other one was a plus. So that's why I asked, but all right. Even 46. Well, I'll ask you one more. What's the least common denominator in 44?
44. X plus 3, X minus 3.
Good. And that covers all four of them. Cole, I will let you run, and I will talk to you next Monday at 3:30. That'll probably be our last session before your final, right?
Yep.
All right. Have a good one. If you have a lot of material and you need extra time to cover it, now's the time to make that decision, okay?
Yeah, well.
It's unlikely the time will be available by next Monday. Everybody's going to be having finals, so.
Mm-hmm.
All right. Talk to you then.
All right.
Bye-bye.
Bye-bye.